Okay, so we're looking at a new distribution called the Poisson probability distribution function, and for the French people, Poisson is actually the same word as fish, but it's not called a fish distribution, it's called Poisson. It's not named after fish, it's named after a French mathematician, Simon Denis Poisson, who lived in 1781 to 1840, and he published this work before he died, luckily. Okay, and there was a picture of him. See, that's a picture of him. Okay, so don't have to worry about where it comes from, but the formula, the probability that a value is obtained is e to the minus lambda, lambda to the x over x factorial. Lambda is the mean, which you'll see in a sec. Excuse me, and the mean is also called the variance in this particular case. You don't have to worry about that unless the question talks about variance. X is the value that you want, and factorial button. So we'll show you how to do it on the calculator, and then we'll show you that there's a table that's already done it for you. So this distribution is a time distribution or a rate distribution. Okay, you'll see in the examples what that means. The values of x that you're trying to get have to be whole numbers, discrete numbers that can be counted. Each occurrence is independent of another. The mean stays constant throughout the distribution, and you can have anything from 0 to infinity. So again, these last couple of points will make sense in a sec. Copy that and come across. Okay, so this is an example. So on average, 3 buses pass a certain spot every hour. So the key thing we have to pick up from here is that there's time is mentioned. Okay, now in terms of the questions, all the questions are asking about in the next hour, which means that we can take that number exactly as the mean. So the questions are, what's the probability that 3 buses go past at least or no more? Okay, so 3 buses is an exact value. So as I said, the question talks about buses per hour, and then the question talks about hours. So that means we can just say that the average is 3. Now using your calculator, the probability that you actually have the number 3 would be e to the minus 3 times 3 to the power of 3 over 3 factorial, and on your calculator to 2 decimal places it's 0.22. I think it's 2240 to 4 decimal places. In the next one, at least 1 means 1 plus 2 plus 3 plus 4 plus 5 up to infinity. Okay, so you can have up to infinity, but you don't do all those numbers because the only number that's missing is 0. So you go 1 minus probability x equals 0. So you get e to the minus lambda, lambda to the x over x factorial, and you get 0.95. And the last one, no more than 3, is 0, 1, 2, 3. So you have to do 4 calculations. Again, you can test it on your calculator, but unless the table doesn't have the value that you want, then you'll be looking up on the table. This is laborious, okay? So there's tables that I'm going to show you on the next page, okay? And you've got a set already as well. Okay, so there's values that are discrete, okay? So these values up here, these are your lambda values, okay? And then you've got probability x equals 0, 1, 2, 3, 4. Okay, so so for instance in this one here, lambda equals 0, lambda equals 1, and the probability x equals 0 is 0.3679. On that previous example, we had lambda equals 3 for the buses, and the probability that x equals 3 was 2240, and on the previous page I had it as 0.22. So you can get the idea. Okay, so they're the discrete values, but the one that's more useful is the cumulative one. Okay, so so for these ones here, you have a cumulative Poisson distribution. So what's happening here is it's adding up all the values less than whatever you like. So here lambda equals 1, and the probability that x is less than 1. It's adding the 0 and the 1 answers together. So the 0 answer is 368. And the 1 answer is the difference between those two, but it's adding up the cumulative. For this particular one, for lambda equals 2.2, the probability that x is less than 3 is just 0.819. So it's adding the 0, the 1, the 2 answers, and the 3 answer to get 819. So it's inclusive of that value there. Okay. So let's have a look at another question where it's not a time-based, it's a rate-based. Okay, so on average a person makes 0.2 spelling mistakes per page. Find the next 5 pages. So talks about per page, and then it starts talking about for 5 pages. So the first thing you have to do or understand is that that is not lambda. So lambda will be 0.2 times 5, so lambda equals 1. Okay, so this is 0.2 per page, and then all the questions talk about 5 pages, so you'd expect 1 mistake per 5 pages. So from there you'll be looking up your tables, and for the first one exactly 2 spelling mistakes. So I'm getting my table out, and for lambda equals 1, so the probability that x equals exactly 2 when lambda equals 1 on my table is 0.1839. Okay. More than 3, so more than 3 is 1 minus, sorry, not p minus, I said 1 minus the probability that x is less than 2. And on your cumulative table, for 1, the value of 2 is 0.9197. Okay, so lambda equals 1, less than 2 is 9197, so you just have to subtract those values on your calculator, and I haven't got one with me, so I'm just doing it backwards. So it's 0.0803, so there's not much chance that you'll have more than 3 spelling mistakes. And the last one, at least 1, probability that x is greater than or equal to 1 equals 1 minus the probability that x is 0. So you look up the 0 answer, and that's 0.3679, and again I've got my calculator, 1, 2, 3, so I think it's 0.6321. Okay. Okay, so copy that and come across, and so there's a worksheet on Moodle. So enjoy. E.